Hello everyone, welcome to Vijay Chemistry. Today, day 13 class. In this video, we are going to discuss the Maxwell relationship in thermodynamics. Okay, please note what is the trick. Good people have studied under very amazing teacher. Okay, based on that one, I'm going to make a Maxwell square. Okay, now see what is a Maxwell square. Now see, simple. Now what is the trick? Good people have studied under very amazing teacher. Okay, listen. G is gas-free energy. P is a pressure. H is enthalpy. Okay, S is entropy. U is what? Internal energy. V is volume. A on the L1 gas-free energy. T on the temperature. Okay, listen. Good people have studied under very amazing teacher. Okay, this is what is like good people have studied under very amazing teacher. Okay, now we have to put the arrow mark. This is very important. Please note. Okay, we have to put the arrow mark to S versus T. S to S T is the first arrow mark. Is the second arrow mark. Okay, now this is called Maxwell square. This is called Maxwell square. Okay, using this Maxwell square, I'm going to derive the Maxwell equation. Okay, see first one. Listen. Now this time U and H and G and A. Okay, I'm going to find delta G formula and delta H formula and delta U formula and delta A formula. Okay, and first one. Okay, I try to find out delta H formula. See, dou H. Listen, understand, listen. Now in dou H, what are the two important parameters? One pressure and entropy, right? We have to put differential form. Okay, therefore I put dou S, I put dou P. Listen. Now this arrow mark. Okay? Now this arrow mark. If you going to take delta H means okay. What is too important? S and P in the same line, right? Now this arrow mark towards S and P, we have to put minus sign. Okay, away from the arrow mark, you have to put plus sign. Okay. Now this S and P arrow mark not towards P and S, right? This arrow mark towards temperature. This arrow mark towards volume. Okay. Therefore I put the plus sign. Okay. Now what is opposite term in S? Temperature. Okay. I put T. In here, what is opposite term for volume? Plus. I put V. Okay, this is a formula. What dou S equal to and T del dou S plus V dou P. Okay, this is the first relation. Now second one. Okay, I will write delta G, dou G. Dou G is equal to similar. Okay, you have to put one. Dou P and dou T. We have to differentiate. Therefore, I put dou P here, dou T. See, P opposite of V. Okay, the arrow mark not towards P, not towards V only. I put plus sign V. You got the point. Now this arrow mark towards what? Towards T. Therefore, I put minus sign. What is the opposite of T? Yes. What is the formula? Delta T is equal to VdP minus SdT. Okay. This second equation. Now what is the third equation? Simple, right? But I write here, okay, third equation. I write delta dou A. What is important? And V and T. Okay. Therefore, the dou V here dou T. See, in this both are towards what? Towards V and P, right? V and T. Okay. Now V opposite of P. Okay. Put minus sign. I put P. Okay. In this minus S D. This is equation number 3. You got the point? What is equation 4? Delta U. Dou U. Dou U. Okay. In this case, why? S and V, right? Therefore, dou S or dou V. Okay. Now this arrow towards V. Therefore, opposite of P. Okay. Minus P. This away from S arrow. Therefore, plus T. Okay. This is formula. This is equation number 4. What is the 4 important formula? First one, dou S equal to TdS plus VdP. And second equation, delta T is equal to VdP minus SdT. And third equation, dou S equal to minus PdV minus SdT. And dou U is equal to D dou S minus P dou V. Okay. This is a 4 equation. Okay. Based on this 4 equation, I'm going to make a other relationship. Okay. What is the first equation? Please note. What is the first equation? Dou H is equal to TdS. I take differential form, okay? Simple. Anything's okay. So DH is equal to TDS plus VD. Okay. Now see, now I'm going to put the condition number 1. See, in this equation now, volume is constant. Volume is constant. It means what? the dP is equal to 0, it means the VdP is equal to 0, right? Therefore, equation become dou H. Dou H, okay? See, dou H by dou S and constant pressure that equal to temperature. You got the point? Listen, dou H divided by dou S, okay? Equal to T. This value become 0. Why 0? Because constant temperature, constant volume, okay? Oh, sorry, constant pressure. This constant pressure. Therefore, this term becomes a 0. Therefore, what is the formula? Dou H by dou S equal to temperature, that constant pressure. Okay. Now, second case, first case, right? And second case, put delta S. Okay, S is constant. Entropy is constant. Entropy is constant mean it means what? TdS equal to 0. Okay, but TdS equal to 0. What is the formula? Dou H divided by dou P and constant entropy that equal to V. You got the point? Okay, this equation. Okay, go to second equation. We're going to try to write this way. What is second equation? Dou G is equal to dG is equal to VdP minus S dt. Okay. Now put the first condition. What is the first condition I am going to put? Okay. Now pressure is constant. Okay. Pressure is constant. Pressure is constant. It means what? dP is equal to 0. Therefore, VdP is also 0. What is the formula? Dou, okay, dG divided by dt, okay, and constant pressure and minus S. You got the point? Minus, yes, very important, please note. Minus S, okay? Now, similar way, okay, I'm going to put the temperature constant, okay, first case. Second case, temperature constant. Temperature is constant. Constant. It means what? dt is equal to 0 and minus S dt. S dt is equal to 0, okay? Now see, now this value becomes 0, upper dg by dv and constant T is equal to volume, okay? Therefore, delta G by dou P and constant temperature that equal to V volume, okay? Very simple, okay? Third equation. What is third equation we wrote? Third equation. That is, okay, dA is equal to minus of PdV and minus of SdV. Okay? Now, listen, in same case, okay, now temperature is constant. Temperature is constant. It means delta T is equal to 0. Therefore, yes, delta T also 0, right? Now, what is the relation? Dou A by dou V, dou A by dou V on constant temperature that equal to minus P. You got the point? Yes, sir. So, with the first one. And second case, okay. I put volume is constant. I put volume is constant. Okay, now what going to happen? This volume constant, this term becomes 0, right? Therefore, dou A by dou T on constant volume that equal to minus S. Simple, right? This equation 3 order relation. Okay. Now equation 4. Equation 4. That is delta U, right? And dou U. Dou U, dou S. Dou U, right? Dou U is equal to, du is equal to, okay, T delta S minus P delta V, right? Now write the equation simple. What is first condition? I'm going to listen to homework. Okay, you can try to write this equation. Okay, first one, put ds equal to 0. Okay, and second one, put dv is equal to 0 and write this two case for delta u. Okay, now listen, I'm going to make one more relation using this 4 equation. Okay, that is very, very important for exam point of view. Okay, this also important. Okay, now one more lesson. This relation number 1. Okay, this relation 4, right? This is 4. Right. This is 5th one. This is 6th one. Okay. This is 7th one. 7th one. This is 8th one. This is 9th one. This is 10th. This is 11th one. This is 12th one. Okay. You can write 11th and 12th. Okay. Now I'm going to write one more relation using what? That Maxwell square. Okay. Please, very important. That is very important. Now start from first equation. Okay. See. What is first? I take delta U. Okay. Delta dou S, dH. ds equal to, wait. First we take du. It's very important. Please note. Du is equal to, okay, TDS minus PD. Now see, that's a very important one. Listen. Now listen. Now, dou T by dou V, dou T by dou V and constant entropy. You got the point? Equal to, put say minus sign and dou P by dou S and dou P by dou S and constant volume. This is relation number 14. You got the point? How I draw, how I write the equation? Very, very important. First, dou T by dou V and constant entropy. So minus, you have to put minus sign. And dou P by dou S and constant volume. Okay. Second equation. Please note. That is delta G is equal to and T delta S plus V delta P. All right, the equation very simple. Dou T by dou P, dou T by dou P and constant entropy that equal to plus sign. Okay, plus right. Similarly, dou V by dou S and constant pressure. This is equation number 15. You got the point? Third equation. Delta U, delta H, delta G and del A, right? Third, delta G. Delta G is equal to, okay, VDP minus SDT. Now, there is the equation. Listen, dou V by dou T, right? Dou V by dou T and constant pressure that equal to, put minus and same, dou P by dou V. Dou S by dou P and constant temperature. Okay, this is equation number 3. This is equation number 16. Now, what is the equation? The last equation, okay? Maxwell relation. Last equation. That is what dou dA. dA is equal to, okay, minus SDT and minus PdV. Now make the equation dou S by dou V. Put minus sign, okay? Dou S by dou V and constant temperature that equal to minus of dou P, right? Dou P by and dou T and constant volume. This minus cancel. Okay, what is the equation? Dou S by dou V and constant temperature equal to dou P by dou T and constant. Okay, it's a Maxwell relation. Equation number 7. Okay, these are Maxwell. Okay, listen. Surely the CUET exam they will ask on Maxwell equation relationship. Okay, I hope you understand and thank you so much for watching. See you in the studio as soon as possible and take care. Bye.